In review, this car is running weird. The idle speed is all over the place and it just runs weird. Sorry, but I don't know how else to say it. There are 3 codes stored, let's take a look at them. The mill is on, so there is a freeze frame. The code in the freeze frame is P1101, Intake Airflow System Performance. The code set criteria for the P1101 is: the engine control module compares actual airflow based on throttle position to a calculated airflow based on manifold absolute pressure sensor, and mass airflow. In other words, the computer is comparing the mass airflow sensor input to what it thinks the airflow is according to calculations using other sensors. If there is a large difference, this code will set. Here is a tip. If the mass airflow sensor is reading incorrectly, then the fuel trim will be considerably shifted either positive or negative. Here we can see that the fuel trim was very modest. I believe we can say that this code set because the other inputs being used for calculating airflow were a problem, not the mass airflow sensor. The next code in the list is the P0513. Immobilizer key incorrect. I think we can dismiss this code for obvious reasons. That brings us to the P0171. Fuel trim system lean. Now this is interesting. The total fuel trim correction is positive 69%. That is huge. This is possibly a fault of the mass airflow sensor. But wait. We need to consider how this code could show up along with the P1101. Intake airflow system performance. Here is the failure record for the code that set the mill. The P1101. Looking at the data, that it is different than the freeze frame, tells us that it is an onboard test that has failed after the one that set the freeze frame. Here again, fuel trim is pretty modest. This would not seem to indicate a fault with the mass airflow sensor. It looks like we have some kind of airflow error but not due to the mass airflow sensor. Let's take a look at some data. This data recording is over 30 minutes long. I've chosen 5 PIDs. Engine speed, mass airflow, throttle position, manifold pressure, and APP. We will walk through this by moving the cursor. During the entire capture, the APP is not being applied. The engine speed at this point is 725 RPM. The mass airflow sensor is reading 3 grams per second. The throttle is at 0.6%. This capture was made with the GM scan tool. The value is correct. The manifold pressure is at 7.2 psi. The cursor has been moved. The accelerator pedal has not been touched. Engine speed is now 853 RPM. The mass airflow sensor signal has not changed much. The throttle is still at 0.6%. Manifold pressure has changed slightly and now is 7 psi. Moving the cursor again, we notice that the accelerator has still not been touched. Engine speed has increased to over 1000 RPM and has oscillated for a period of time. The mass airflow signal has dropped significantly to 1.74 grams per second. The throttle blade has increased to 1.6%. Manifold pressure followed the changes in RPM. Let's move the cursor one last time. Once again, no one is applying the accelerator pedal. Engine speed has stabilized around 1000 RPM. The mass airflow signal is steady at 3.48 grams per second. The throttle position is now at 2.9%. Manifold pressure is at 6.7 psi. So what is going on here? The engine appears to be receiving air from another source than through the mass airflow sensor. The answer to this puzzle is to look at the PCV system. This system is unlike most systems found on engines. Normally, fresh air flows from one side of the engine to the other and then into the intake manifold through a PCV valve. This one doesn't use fresh air. Crankcase vapors travel upwards through the cylinder head and then to the PCV valve. The valve is spring-loaded open. The passage is then connected to the intake manifold using a one-way check valve. The valve opens when the pressure in the intake manifold is less than the pressure from the crankcase. The crankcase vapors are also connected through the PCV valve to the turbocharger inlet through another one-way check valve. The check valve will open if the pressure from the crankcase is greater than the pressure at the turbocharger inlet. Let's take a look at normal operation. Here is the PCV flow without boost pressure. The check valve in the intake manifold is open. The check valve at the turbocharger inlet is closed. Crankcase vapors are pulled in through the PCV valve into the intake manifold. The rate of flow is determined by the manifold pressure. Under high vacuum loads, little to no crankcase vapors will be purged. Under low vacuum loads, a substantial amount of crankcase vapors will be purged. When the intake manifold is receiving boost pressure, the check valve in the intake manifold will close. This will prevent pressurizing the crankcase with boost pressure. Crankcase purging of vapor through the intake manifold will not occur. If pressure in the crankcase is greater than the pressure at the turbocharger inlet, the check valve at the turbocharger inlet will open. This will cause the crankcase to be purged through the turbocharger inlet. So, what does this have to do with our problem? The check valve at the turbocharger inlet was missing from the hose. The check valve in the intake manifold is open at idle. This creates a path for air into the engine that is not measured by the mass airflow sensor. The ECM was doing what it could with the throttle body to control the airflow. That is why we saw the throttle position at 0.6%. I replaced the plastic hose from the turbocharger inlet to the intake manifold and the problem was fixed. Thanks for watching.